What's up? I'm Brianna Ivy, and this is the Hear from a Student podcast. BJ, what's up?
What's up, Brianna?
It's so good to see you. Thank you for taking some time out of your day to hop on this podcast with me.
Nah, it's no problem at all, man. It's always nice catching up with an old colleague or classmate.
Yeah, man.
Classmate. I'm saying colleague now because, but classmate.
Apparently we're adults. That's what they keep telling me, but I understand.
Apparently we're adults. I'm not really buying it.
Me neither. But I know you, of course, but introduce yourself to the people. Let us know your name, what you study in school, where you went to school, and where you're from.
Okay. Hello everyone. I'm BJ. I am Nigerian. I went to Georgia Tech where I met Brianna. We actually met in a class that I had to take and she also had to take. In undergrad, I actually was a chemical and biomolecular engineering major. Now I don't do much of that. I actually am a technical product owner at Georgia Pacific.
Wow. And we're gonna get into that. But
yeah.
So take me back to BJ senior year of high school. You're trying to decide either which one came first, what you wanted to study or where you wanted to go to school at.
I think I had a very unorthodox approach coming into college. Mainly because my last year of high school, I actually wanted to be a plastic surgeon. Fun fact, Brianna didn't even know this.
I didn't even know that.
I know. I wanted to be a plastic surgeon.
Okay.
But at the same time, I felt like the degree of getting a medical degree is like a long course to actually go through. So all those years of going to college, medical school, residency, I feel like it was a bit long. So I wanted to get into a degree that was going to give me the flexibility if I wanted to go into medical school, and if I didn't want to go into medical school. So that led me into deep thoughts about what kind of engineering and what kind of degrees can do that for me. So it came down to engineering, and I knew for a fact that I liked chemistry, I liked physics. That was my thoughts back in the day. If you like chemistry, in my mind, you should like chemical engineering. By the way, that's wrong. FYI.
We're gonna get into it, but thank you for that foreshadow.
Oh, for sure. Just letting you know. But point is, I did some research into what kind of engineering I was interested in. Chemical engineering was when I aligned the best with my interest, as well as the fact that I knew that a lot of schools had pipelines into medical school with a chemical engineering degree, that or BMed, biomedical engineering degree. So I said, okay, cool, I'm going to go into chemical engineering. Now, what school do I go to? So in my case, to answer your question, I think the answer of what's my degree came first, and then what school to go to came afterwards.
Okay.
Now, the reason why I say it was a bit unorthodox for me is because I did have a plan to go to college and medical school at the time in Canada.
Okay.
So how Nigeria works is you have some schools that are British schools, and we end with a year 11 or year 12. Because America ends with grade 12, we end with a year 11. So I had to come into Northern American school system and do one grade 12. Okay. Just 1 year. So the 1 year I did that in Canada with a plan of going to college in Canada. But then last minute, my mom decided to move me to America.
Mm-hmm.
So moving to America last minute, I had missed Georgia Tech's deadline to apply. So I had to end up going to a community college for about a year or so, and then transfer into Georgia Tech.
We've known each other for so long. When was I gonna ever hear this story?
I feel I don't know, it just never came naturally because we always had conversations about everything else, but about how did we get here? You understand?
Yeah. Oh my goodness. First of all, so you grew up from childhood to grade 11 in Nigeria?
In Nigeria, yes.
I really don't know what I thought.
You thought I grew up here?
Obviously, I'd be wrong. If the first 10 minutes has taught me nothing, I'd be wrong. So, wow. Okay. So, that's crazy. So, what was I guess the transition, like from that first year of community college to your first semester or so at Georgia Tech?
I mean, I think like ultimately it's a very difficult position to be in. And I will say that because like for every stage of your life, you develop a habit. You develop a habit pertaining to that stage. Like you go into high school, you develop a habit for studying, how you study, you balance it with different sports. In my case, I played soccer. So obviously I balanced like call it like high school with soccer, and that was about all I had.
Yeah.
But then for a lot of other folks, like I feel like they don't really have that kind of balance, I would say. But in the case of transitioning from like high school and all of that, or from I'll just say like community college into like Georgia Tech, it was hard because I had developed the habit of studying,
Mm-hmm.
or I thought I knew how to study via my community college. Every school is different, everywhere is different. Community
Yeah.
college, I thought I knew how to study. So my first semester at Tech, there were a lot of like resources I had provided to me, like from the Transfer Student Association. They were like, like it might be hard to transition to Tech. This is some things you should have to support you. These are some extra classes you should go to. But the reality of things is that once you think you know how to study, it's hard to listen to somebody say you don't know how to study, especially if it was working for you.
Yeah.
Understand? So I think my ultimate realization to not knowing how to study was, how GT had like hell weeks, where it's like
Yes.
like the fourth, I think like the fourth or fifth week of college, basically.
Yeah.
Like after you come back into like I think the fourth semester, you have a hell week.
Yeah.
Hell week, exams, classes, tests, all these different things, in addition to like a career fair, a
Yeah.
big career fair. So that's what makes it hell week, obviously. You're aware of this.
Mm-hmm. Yeah.
But then that was week that told me that I didn't know how to study because I had 4 exams for my 4 classes and the results were not very pleasing.
Yeah.
So for my transition, I had to now start outsourcing people who were in my same major or
Yeah.
people who were in my same boats. So I tapped a lot into the Transfer Student Association
Mm-hmm.
for like people who did like dual degrees because a lot of schools offer 2 3s. And 2 3s are basically you do a 2 year associate degree at a different school, and
Mm-hmm.
you come to Tech for your 3 years of like your actual major. So
Yeah.
technically, you have an associate degree and your actual major. So a lot of schools do that. And in my case, I actually do have an associate degree, but I don't really use it. Mine is in biochemistry. I don't really use it. So it's more so my actual degree that I go for. So I had to reach out to a lot of people
Yeah.
who also transferred to Tech, similar experience. How did you study? How did you erase how you used to study and how did you start studying?
Yeah.
So learning those new like values and those new like skills were the major things that helped me transition into like my time like beginning first semester at Tech.
Yeah. You know what? First of all, I'm learning so much about you in this episode, but also it's amazing how you went when I was going into Tech, I knew Tech was hard, right? Everybody said that, whatever, okay, yeah, we get it. But I also thought I knew how to study, and I only was studying in high school, and I barely did that. And it's crazy how that first hell week really just knocked the wind out of every single student who ever attends.
Everybody.
Because you really just understand, like, you have not taught yourself this information. And for me, it was like high school everything came so easy. It's like I didn't really have to learn it. I just remembered it, or like the process was different. And then coming to Tech, it was like either you're gonna learn how to study or you're gonna fail. Pick which one you would like to do.
Your
And
choice.
it's your choice. It's your choice. So I feel like that first semester, I really took all of the resources for granted, all the OMED tutoring, all of the academic for the student, what is it? Center for Academic Success. I took that for granted. Like they have so many resources to help you. But in my head, I was like, I don't need it. Then I got that calculus test back and I was like,
calculus.
I need everything that I could possibly have right now.
Sure. I
So
need everybody. I need everybody to help.
every human that's here that can help me, professors, TAs, tutors, I'm setting up meetings. So it's so interesting to hear everybody's story with how they reckoned with the fact that, wow, I really don't know how to study.
Yeah,
So
yeah. I think I think everyone comes to that realization at
yeah,
different points in time
yeah,
because like you always think you know how to do something. So you're faced with a challenge that challenges you on do you really know how to do it? And then now
yeah,
you have to either a lot of times you have to readapt. You understand? You have to readapt
yeah,
into like what works best for that situation. Like you have to now relearn how to actually study for Georgia
yeah,
Tech.
yeah,
Because with that being said, how you study even post Georgia Tech
yeah.
is also always going to be different. You understand? So you always have to be open to like readapt in my eyes, anyways.
Yeah, and depending on the professor you have in the class you take, and you might have to switch up how you study on a class by class basis. But once you have the foundation, I think having the foundation is what sets you up for success. Once you understand how you learn and how you best retain information, and then you can
Mhm.
keep that and adapt that to different classes and professors and so on and so forth. But yeah, what did when you started getting into your what is your full major? Is it chemistry and biomolecular engineering?
So it's chemical and biomolecular engineering. How were
Chemical.
you at Tech for that many years and you don't
Because
remember
that
what
major
your major?
always confused me. Because why is it so many words? Chemical and biomolecular engineering.
I mean, ECE is a lot of words.
I'm electrical. I don't know where the computer come in at, but I understand. But when you started getting into the classes, did you realize you had any misconceptions about what that discipline entailed and like what it truly was versus what you thought before going into it?
I think so, yeah. I think so because, like, as I said earlier on, like chemical engineering, the biggest misconception a lot of folks have about chemical engineering is that if you're good at chemistry, ideally you want to be excellent at chemical engineering. You're going to be like just good, blows out the wind, cool.
Yeah.
I thought that as well. I am very my thought process was very misconstrued, very,
Mhm.
very misconstrued, because a lot of chemical engineering actually just leads to like derivations, physics, mathematics, some chemistry, like maybe like a sprinkle of chemistry, but
Yeah.
then like, that's not always the case. So I guess in my case, like from day one, teachers at Tech will tell you
Oh,
that's the one thing I enjoyed about GT. From day one, whether you get it soft or you get it hard, you're going to be told what to expect.
yeah.
They will never lie to you.
Well, that's
Yeah,
good.
100%. Like, I think I remember his name because he actually was my reference for a couple of things later on in life. My first chemical engineering class was ChBE 2100, and it was with a new professor at the time. His name was Cuba Torres.
Okay.
So he basically, like, in the class, he basically said, how many of you are good at chemistry? We always a hand up, like, this is cheese. Like, that's all I hear. What do you mean? How many of
Yeah.
us are good at chemistry? And then he goes, forget everything you know about chemistry. Everything I'm going to be learning is very heavy on physics-based derivations and common sense. They call it common sense in chemical engineering because you learn to have the common sense. It's not really common sense.
Yeah.
So he gave us that 411 and from an off rip, I was like, I have to find a friend in this class because this is not going to make any sense.
Yeah.
So at that point in time, I basically went around introducing myself to some different people like, I'm BJ, I'm new here, I'm new here, like let's study, let's do this and that. But also my way of studying wasn't really gelling with their way of studying
Yeah.
because I came into a 2100 class, which is a second year class. I came in as a transfer,
Yeah.
but then a lot of folks in that class were already freshmen. So they developed a habit for Georgia Tech earlier
Yeah.
than I did. So I took a step back and I said, that's when I thought I could do it on my own. I was like,
Yeah.
I'm calm on my own, I'll be straight. Until the whole first wave of exams, and I was like,
Yeah.
what were you saying your name was again? Yeah. Yeah, I think that's really what it is.
Yeah. The ability that I had to develop this because I don't know that I went into classes thinking I could do it on my own. I probably did. Let me just be honest. Probably did. I 100% did. But like realizing how much easier it is when you can form, like once you understand how you study and how you learn, forming those like study groups, especially when I got into like the ECE classes for real. Because let me tell you, I used to be upset when people would mess up the curve, and I still don't like that. But then I would just find the person who did mess up the curve and start studying with them. I'd be like, I'm Brianna.
Sure.
And then also, what do you do after class on Wednesday at 5 o'clock? Because we should meet in the library and we should talk about whatever you did on this exam that I did not do. And that, that really got me through a lot of classes because what I didn't know they did. And we were able to collab once I understood how I studied and what I had to do prior to like studying with a group, studying on my own first, then studying with a group. Very, very instrumental in my success. So
yeah. And we also had that we also had a study group actually. I think that's a piece that we need to mention as well. The fact that we actually met, I think, via study group that was put together by, was it Peter or Chamara that put it together?
I don't even know. It was one of them. I think it was Peter.
It was somebody that put a study group together, and myself, Brianna, and two other friends were part of that study group.
Yeah.
And that group saved my life. So.
Come on. Because MATLAB, yeah. Shout out to Peter and or Shamar, whoever put that group together, saved my grade in 1371, which is not even a requirement anymore for freshmen. So yeah, I think the requirement is Java, if I'm not mistaken. I can't remember.
Oh, it's switched to Java?
Yeah, they switched to some other, it's still a computer science class or language, but they switched from MATLAB to something else. So
that's not bad. That's not bad. I think Java is more scalable.
I know a lot of people got beef with MATLAB, and I understand. Let's move on. So
don't let me start.
let's not even get into it. What were some of your favorite chemical engineering classes, and then some of your least favorite classes?
I need to answer this question. So I think my favorite chemical engineering classes happened in spring of 2019. I know this very well because as chemies, we take a class called Trifecta.
Oh, okay.
And it really is a combination of thermodynamics to transport and fluid dynamics, and then a separations course. And basically, lots of folks go into this semester and they break off the workload. They do 2-1, or you can do 1-1-1.
Okay.
But there's also some stubborn people like myself. Stubborn. I say this because I regretted it at some point, but I said, I'm seeing this to the end.
Yeah.
Stubborn who end up taking the 3 classes at once. So I think the reason why I think that was my favorite batch of classes is because from the moment you start chemical engineering, like orientation, they let you know what the layout is. They say you want to graduate from chemical engineering from Georgia Tech. If you can do all those courses in 3 years, you're good. We don't really care where you're up to. Goodbye.
Yeah.
That's the beauty about chemical engineering. But the issue is there's a lot of courses to cover. So it ends up taking more than 3 years, obviously. Yeah. So I guess in my case, from the moment I had my transfer student orientation, a big thing that was mentioned was the fact that in your 3rd year, end of your 2nd year, you'll be taking a trifecta class, and it's basically the hardest semester of your life. That's what they always tell you. So I think what really got me through that was the fact that I had like a crazy expectation for this semester. I'm like, I'm not playing around this semester. Yeah. I'm trying to get this and that done. So those 3 classes end up being like, I think my favorite semester in college, just because I forced myself to not only like learn the material, but to actually enjoy it. I said, if I'm going to be here struggling, I have to enjoy it.
Yeah.
And a thing that played a good factor in that is 2 things really. The previous semester you take transport 1. Okay. And the next semester I take transport 2. So I say that because the teacher that teaches transport 1 taught transport 2. Okay. And I'm the kind of student where if I have an issue, my first pass at the issue is, what's the professor think? Yeah. So I used to camp out in front of his office all the time, just like, I need help. Like, he'd be like, oh, I'm busy for the next hour. Can you
Yeah.
wait? And I'll sit right there and I'll wait.
Yeah.
And sometimes I'll walk with him to like his lab and just like hear his answers to my questions, and we'll have conversations.
Yeah.
So I built a good rapport with the transport professor so that when we enter transport two and he walked it, he wasn't my teacher class
Yeah.
originally when I signed up, but he walked in as a replacement professor. They said this semester he's teaching a class now.
Yeah.
I was very excited because obviously it meant that like we can continue our rapport and things just kind of mesh, because a lot of people have issues because like what Professor A taught them in class one is not a continuation. What would not be continued in class two.
Yeah.
But since he taught all of us class one, it was kind of a smooth transition. We left off here. This is where we'll continue from. Was the first thing, and then for thermodynamics two, the professor was the only black professor in like the chemical engineering like class. So
Yeah.
we felt comfortable with him as a professor. I would just say that. I think that's also a very important piece of things.
Yeah.
That a lot of people don't understand that representation in that case does matter. Professor wise, like at your workplace, like a co-worker, like your mentee, your mentor. I just feel like in general, like for school in that case, like it meant a lot having a black professor who knew it all and who was very well respected in the community. Because if he said this was right, there's not a lot of folks who can say it's wrong.
Yeah.
So it's very comforting, and it just allowed us to even learn the class more, because now we're not only into it, but then like the professor is also personable enough that this material doesn't go over my head.
Right.
Yeah.
Wow. What is the content in transport, thermodynamics, and what the separation course?
Yeah.
What high level, because I'm electrical, what were you learning in those three classes?
So let me start off by correcting. I said thermodynamics 2. That was the previous semester. I meant to say kinetics. Kinetics is the third one.
Oh, okay. Kinetics. Okay.
Yeah, so three of them. So the contents, I think like the contents at that point in time was very much geared towards senior design.
Oh, okay. Okay.
And then so the reality of things is that a lot of people graduate from chemical engineering, like institutes, like schools that have that major, and they go into the field. They go into the plants, they do what they want to do. Now, there's also a handful of people who don't want to do that, who don't want to go into the plants, who don't want to build reactors. So that class is very much geared towards like, if you have interest in this is core chemical engineering. Like, this is like what you sign up for. Because it spoke a lot about separations, was like petroleum, you have an oil distillery.
Yeah.
How does separation work based on like the distillation processes from crude oil, how each one goes at different boiling points?
Yeah.
So that was one thing, basically like about separation of different things.
Okay.
That's the first thing. Kinetics was more reactor design and reactor build.
Okay.
A lot of folks like are still going to work with reactors. And I found out after I graduated that there's numbers on the reactor screen. You don't have to actually calculate it. Don't listen to that part because obviously that's but point is that a reactor design was a course I had to take. Yeah. So we had to simulate MATLAB reactors. And I actually enjoyed MATLAB a bit. It had a lot of restrictions. Okay. I enjoyed it a bit. It had a lot of restrictions in terms of what you could do. But for the class, it did what it needed to do.
Yeah.
Point is. So that was kinetics. Kinetics. Transport 2 was also similar to separations. Okay. Because basically separation was like how you separate crude oil into different like gas products. But transport was more so about like the process of like the different fluids involved in the process. You have like viscous, non-viscous, you have all these different things involved in the process. You have to think about outside of separation, like going into the like distillation column for separation. How do you think about those liquids? Things like calculations for dimensionless numbers. It was a lot of calculation that I didn't mind. It made sense then.
Yeah. Back then, yeah. Back then, a lot of stuff made sense. Today, if you ask me to look at an integral, I don't know what to tell you.
What do I do with that? Like, what do I? I'm gonna plug it into something. Like
I'm a Google integral calculator, and I'm gonna put it in there because that's what we do in the real world.
That's what we do in the. That's what a real engineer does. You figure it out.
Figure it out.
You figure it out.
So you touched on your favorite classes. Did you have a least favorite class or a class that was like, if I would have never had to take this, I would have been okay.
Did I have a least favorite class? I did have a least favorite class. Um, very interesting one. Because my least favorite class was actually the last chemical engineering class I had to take.
Okay.
I know why it was my least favorite class. I don't think it was my least favorite class due to content.
Okay.
I think my least favorite class due to interest. Because basically for capstone is the last class you take in engineering and Georgia Tech. Capstone is actually is the last class I take at Tech.
Mm-hmm.
And a lot of folks oftentimes take capstone as the only chemical engineering class. And that's because obviously they broke down the classes I spoke about earlier on, the three
Mm-hmm.
classes. So they have space to bring in forward any other classes.
Yeah.
But in my case, I had to take capstone with a class called process control.
Okay.
The class, I believe, I probably had no interest because it was my last chemical engineering class.
Yeah.
At that point in time, I feel like what really matters becomes application of
Yeah.
everything you've learned. So in my head, if I'm in a capstone course that is meant to cover everything I have learned as a chemical engineering degree, as a chemical engineering major,
Yeah.
why would they put it the
Yeah.
same semester as capstone, this process control class,
Yeah.
if I'm meant to be applying my knowledge into a class? So in my head, thinking that way, I felt like this class is just unimportant. It's just
Yeah.
you understand? And I think one of the big things that saved me from this class, because God knows that someone might have seen me with the way I was going with that class. I COVID happened.
Yeah.
COVID happened, so professors were a bit more lenient with like course load, course material, tests, and things of that sort. So I think that's what ended up saving me because now I was like, I have time to just do what I
Yeah.
need to do. And the girl was like 2 weeks away from school. And I knew what was going on in this class. I just said I had to sit up for my last, I think it was like COVID happened in March. So I think I had 2 more months of the class that I had to take, or less than 2 months of the class that I had to take.
Yeah.
So I just told myself I had to sit down and get it right book. And cause it was a bit slowed down, because COVID slowed down the motion, it
Yeah.
enabled me to catch on and then do what I needed to do. My least favorite class by all means, because I felt till today, I have never used a process control loop in my life.
Yeah.
I've seen one, I've
Yeah.
discussed one,
For
but then
sure.
anybody with engineering knowledge can discuss a PC loop, in my opinion. But to actually think about creating controllers or programming some controllers for use, I think those things were just taught
Yeah.
and of no value. Doesn't mean you shouldn't listen to your own PC class, but
Yeah.
that's my point of view.
Okay. Okay. What did projects look like for uh your major?
Project, I think it depended on the kind of projects or the kind of class.
Okay.
So example would be like thermodynamics is really the study of temperature and how it interacts with A, the human body, and B, objects around you.
Yeah.
So one project that we had was like testing for conductivity for a metal ball,
Mm-hmm.
and there's different ways to do that. You can test for it by putting a probe, like a probe with the pin inside of the metal itself, and that was the final test that we had. You had to, I think, like boil some water, put it in there, and guess the temperature after boiling water for a certain amount of time.
Yeah.
So we had projects like that, and that was like those are group projects which involved some MATLAB, involved Aspen, which is like a chemical engineering tool that we use to simulate
Mm-hmm.
key projects, simulate different like items of the sort. The point is that we had different projects,
Yeah.
and we even had one of those kinetics. The course I told you about earlier on in
Mm-hmm.
the for trifecta kinetics. We had a project to build a mini reactor,
Oh.
and we're given a reaction to actually operate with.
Yeah.
The reactor simulator has to use MATLAB, a lot of MATLAB,
Yeah.
and they also had to use Aspen. So you use MATLAB to access Aspen, which for some reason they spoke to each other in whatever language it was,
Yeah.
and they gave you Excel sheets that had your data.
Yeah.
and you could do what you wanted to do with that data.
Yeah. Okay.
So we had projects that were just very data heavy. And
Okay.
I think that was one of the reasons why a lot of folks actually didn't like chemical engineering at tech,
Yeah.
because it was the most theoretical, in my eyes, it is one of the most theoretical majors you can come across.
Yeah.
Because bear in mind, I my entire career at tech, I didn't carry out any experiments like by hand.
Yeah.
You understand? It was like the most we did was the board that we had, and you put it inside cold water and hot water to test the conductivity limit for like the ball and how it conducts heat.
Yeah.
Like that's the most we ever did. But then that in itself wasn't really like a chemical engineering project that you put your hands on.
Yeah.
You typically get your better experiences with chemical engineering projects like once you graduate or if you're interning on a plant.
Yeah.
That's
Okay.
when you typically get to apply a lot of things. But a lot of it was theory. So it wasn't a lot of like hands-on knowledge, nitty-gritty things going on. It
Yeah.
was more so imagine this ball.
Okay. I was gonna ask, did you have any internship that you really enjoyed, that you had a project you was like, oh, this is what the application of chemical engineering looks like practically?
I think so. I never actually had like a chemical engineering internship,
Okay.
which is again very unorthodox.
Yeah.
I had a lot of interests for chemical engineering, but I had those interests for applications
Yeah.
that I had interest in. Now, let me just explain. I'm using the word interest very all over the place.
Yeah.
Now, it's more so like, for example, my first internship was a research internship. I had to research production of a drug. It was
Okay.
like stuff in my drug. I had to research how to create it, like from the beginning to the end, figure out a way to hypothesize and all these things that I had to like basically present at the end of my project.
Mm-hmm.
So I worked with a team to get that done, and that was a lot of organic chemistry. We had to have multiple variations of we go to the board, we say this is what we're trying to make, we draw the structure, and
Mm-hmm.
you say how do you get from point A, which were the materials that we had. I don't remember, I don't ask. This is
Okay.
2015, 2016, a long time ago,
Yeah.
2017. So it involved a lot of like just like brainstorming,
Yeah.
organic chemistry. But again, I thought I loved chemistry.
Yeah.
I thought I loved engineering. So that was the first project I had and first internship I had. And then my next internship was also research heavy,
Mm-hmm.
but it was research heavy in the biomedical space
Okay.
because I worked with GTRI, and our project was actually contracted by the Department of Defense.
Oh, okay.
It actually just involved a lot of creation of biomedical device. I can't really go into it because of like some things,
Yeah.
time, whatever. But point is, I can go into idea of what we created. We created
Yeah.
some biomedical devices that help like frontline soldiers with any disease like detection, as well as people in like third world countries who don't have access to a lot of like like medical researchers, a lot of like tools needed for like medicine, like
Yeah.
as little as let me think of something that's not related to what I did. Let's say a researcher in my eyes for anything medicine needs a microscope. Let's
Okay.
start there.
Yeah.
Now there's a cost associated with shipping a microscope from, let me think of a third world country. I can't think of a third world country,
Okay.
but there's a lot of transportation costs involved in shipping a microscope from here all
Mm-hmm.
the way there.
Yeah.
Now, what our project was involved was how can you cut down our cost? And our solution was 3D printing.
Mm. Okay.
So most of my project was around 3D printing, like biomedical devices, two biomedical devices, particularly that also utilize optochemistry, which is the use of optical lasers. I forget what it's called, optical lasers,
Mm-hmm.
and basically use optical lasers, lenses, and like the 3D printed devices that we have to build biomedical tools. And instead of having to ship it, it was more so we send them the files, the CAD files. So
Yeah.
I had to learn 3D printing as well. I had to learn how to use AutoCAD. Like, I had to watch a lot of videos. I messed up a lot. It was expensive. It was expensive, because like
Yeah.
3D printing has its own costs.
Yeah.
But then as an intern, you're allowed that leeway to learn.
Yeah.
So per my mistake, I went back to the drawing board. And the beauty of things is that I really like how delicate AutoCAD is.
Mm-hmm.
You have to be very specific with like your measurements, because we also build tools that like needed like very pinpoint accurate things.
Yeah.
So like I would build on AutoCAD, and I'll like print it out, and to just be a smidges off.
Yeah.
I had to come back the next day because of like 3D printing takes a long time and there's a queue. So that happened a lot.
Yeah.
So I really enjoyed that internship because I feel like it exposed me to a lot of real world applications. It was my first exposure to real world applications,
Yeah.
to just like engineering in general. Like I'm
Yeah.
building something that people who need it are able to access it at will. And
Yeah.
it's also like I feel like I was helping people who needed it. Third world countries,
Yeah.
they don't have these resources. So it was really a big thing for me.
Yeah.
But I guess again, to tie back to your original question, I didn't really have a chemical engineering, an ideal chemical engineering like internship.
Yeah.
But then one thing about chemical engineering and engineering in general, from what I believe, is that you're being taught how to think.
Yeah.
So I was able to apply my chemical engineering knowledge just to think
Yeah.
in general. But I think overall, like no internship, but then capstone was probably my closest like hands-on, or just like closest
Yeah.
big chemical engineering project I had to step into. And I think like I really enjoyed it. But would I do it full time? I don't think that was my interest at the time
Yeah.
anyways.
What was that more like the plant type separation arc reactor stuff for the capstone?
Yeah. So it was a lot of simulation, very high
Mhm.
level. We had to create a drug,
Okay.
top to bottom, and we had raw materials for this drug.
Mm-hmm.
Part of the project was, how can I purify this raw material to 99.9% of what we want, while optimizing things, while reducing things like costs.
Mm-hmm.
And when it comes to a separation process, you reduce things by cost by looking at what is separating the different like items. In my case, it was a distillation column.
Mm-hmm.
And you can separate anything if you put a line of 50 distillation columns, it will separate it for you. But then now you bought 50 distillation columns.
Yeah.
A column can be as big as 100 feet to 500 feet.
Yeah.
So imagine a company having to buy 50 to separate one thing.
Yeah.
My part of the project was, how do I optimize this process to reduce how many columns it was. So it was a lot of like research into like columns,
Yeah.
number of trays, a lot of research into like the raw materials, looking at old PhD programs, not programs, but old PhD papers as to
Yeah.
how it's done. So I think that was my biggest exposure to like a chemical engineering project in general,
Mm-hmm.
mainly because also like all I dealt with was like I did some economics, or also
Mm-hmm.
because like if I'm going to work with reducing the cost, I have to understand what
Yeah.
our end number was first, and then see how I can go from that and cut it by like as much as I can.
Yeah.
I think overall I think it ended up pretty well.
Yeah.
It was unfortunate that COVID happened. I
Oh
say it was
yeah.
unfortunate now, and I said it was fortunate before.
Yeah.
It was unfortunate COVID happened because my team actually placed in capstone, but
Oh.
we couldn't receive like our award like in person. It was kind
Yeah.
of sad. And to today, GT owes me the money, because if you place in capstone because you place second, I think you get like your team gets like 600 or like
Yeah.
700 bucks. It's GT still owes me my money, so
Oh wow.
yeah, it helped me.
Yeah. We're gonna have to next time you go up there and play soccer, you need to knock on some doors.
Fair enough.
Okay. So before we transition into uh corporate BJ, what do you think college and your experience at Georgia Tech taught you about yourself?
I think that's an excellent question, because I think about that a lot actually.
Hmm.
Because I would love my kids to go to tech. I sound crazy.
Yeah, you do. So tell me more.
Tell you more. Tell you more. So
Yeah.
I think ultimately when it comes to college teaches you how to think and how to balance.
Mm-hmm.
Those two things I think ultimately become the principles of life. How do you think on your feet? How do you think when you have time? How do you think when you don't have time?
Yeah.
and how do you balance everything you're thinking about with what you're actually doing in your real life application?
Yeah.
Two very important things. Now, the reason why I think college helped me to learn how to think was because chemical engineering, it has a way of broadening your mind, not only to possibilities, but just to ideas
Mm-hmm.
and learning how to think outside of the box. Like you basically like taught how to, let's say, I taught how to build this wallets. You're taught
Mm-hmm.
to build what's chemical engineering, and the end product is this wallet.
Yeah.
But then what they also teach you is what happens if I throw this away. If I throw this away, how it I'll just say for lack of better terms, how it combusts,
Mm-hmm.
how to tear it down. They
Yeah.
teach you beyond the scope of what you're meant to learn is my ultimate point.
Yeah.
And I think that has a way of broadening your mind because now when you see this outside, your mind is not only on this, your mind is curious to know what happens. How do you get raw material for this? How did it go from raw material to leather? How do
Yeah.
you go from leather to like the design or whatever it is on the wallet to like how it goes from when you throw it away, what is the recycling process of everything? It kind of makes you think a lot.
Yeah.
So I think that was very essential. And when I say balance, I mean balance because like in my case at Tech, I was a member of like I was a Kappa at Tech, I was in NESB, SGA as Chemi rep. So I feel like I did a lot of things that I had to learn to balance.
Mm-hmm.
Well, a lot of people, I say I had to learn to balance. I wanted to learn to balance because
Yeah.
not everyone is good is greatly suited to do those many things as at once.
Yeah.
I wanted to learn to balance that because I feel as though, and even till this day, I'm best productive when I have a lot on my plate.
Yeah.
When I have things that I have, when I say like let's say I have 5 things to do, if I
Mm-hmm.
tell myself I have 1 hour, so 5 things, it's like 12 minutes an item. So I have 1 hour for all these things. I will make sure at the 12th minute I'm flipping from thing one to thing two,
Yeah.
thing two, thing three, 12 minutes as we go about. And I think that's a very important skill because when it comes to just like life in general, I think it's just important. You understand? Like
Yeah.
you have a lot to balance, like between work and in some cases school and work.
Yeah.
It's just a lot you have to learn to balance. So I think like tech definitely showed me, that like it showed me how I prefer to balance my things,
Yeah.
how I break down my day, how I how I adapt it to different items. Like the one thing that stuck me at tech was just like using a physical like candle like this, something
Yeah.
like this. I've had this every year.
Yeah.
And it even finishes. And people ask me, how did the candle finish? I just write inside of it. I don't know.
Yeah.
Yeah, so I think like balancing and just having an idea of like I just learning, I just like learn how to think. I think are
Yeah.
two things that college in general taught me.
That is a great answer because yes, I second both points because you learn how to think because you'll get like the technical part of whatever your discipline is. Like, of course, they'll teach you that, but also just making you think outside of that is very important in life in general, in whatever your job will be, and balancing because most people who attend the college will do something other than go to class because that is you should do something other than go to class. You should join orgs that you enjoy. You should join orgs that grow you as a person, as a professional, like like you mentioned NESB and all the orgs that they offer. You're going to do something besides go to class. And so it does teach you how to balance those things and be involved in multiple areas and still show up and be your best, which I think, like you said, is a phenomenal skill. So shout out to Georgia Tech for that. They teach you a lot, but tune in to this guest episode of the Hear from a Young Professional podcast to learn more about their current role, how it compares to where they thought they would be after graduation, and how they're establishing themselves as a young professional.